Welcome to AI Talks, a place to come and listen to IBM customers, partners, and colleagues talk about the digital organization and how AI, hybrid cloud, and enterprise software is critical to success. Let me hand over to my colleagues to get us started. Welcome to AI Talks podcast, and I'm very pleased today to be joined by my colleague, Stephen Rooks. Hello, Stephen.
Good afternoon. Hi.
Good to have you on the podcast, and especially pleased to introduce one of our business partners from Harmonics, Ed Liversidge, who is the director and in his words, also the janitor. Hello, Ed.
Hello there. Hello, Paul.
Welcome to our podcast. Now, Ed, it's a very relaxed affair. It's not mastermind in terms of we're going to drill questions at you. We just want to get your personal point of view on a number of things. Particularly excited that you're one of our newest partners. Steve, did you want to kick off with Ed?
Yeah, sure. So welcome, Ed, to the sort of wider IBM ecosystem and family.
Thank you.
Can you give us a bit about your background and also what Harmonics is all about?
The full title of the company is Harmonic Software Systems. And obviously it's my company. I've had it for over 20 years. And the company specializes in real-time embedded software development and testing. Now, just to explain a little bit about what that is, an embedded software system is anything from, say, photocopiers to helicopters. It's a chip that goes into some box somewhere, which will control something. And, most of these embedded systems are completely hidden. There are billions of them out there. And on the real-time side, that's where you might be controlling, say a helicopter. And in a real-time system, the last thing you want is to get a late answer. As soon as you press that button, you want to make sure it responds within a certain time, every single time. And if it doesn't, you're in trouble.
I mean, we're used to IT software development and those sorts of environments. I've got a background in sort of embedded software development, and I do think it's a slightly different breed of person and be working in that sort of environment. Mistakes
can be very, very costly. The worst type of mistake that can happen is if a human life is lost in an aircraft. So that's called DO-178. That's the maximum amount of kind of software quality that you can put into a system. And so you have to be very, very careful and very, very thorough with your software development, your requirements and your testing in order to produce a system which does what it's supposed to do.
The offering you've got to your customers is deep expertise around sort of embedded software development and testing, but also familiarity with, because I think you specialize particularly in some of the Wind River VxWorks stuff.
Yes, that's right. So I've been using VxWorks since 1995.
Right.
So there's an awful lot of experience there. Wind River are one of my best customers. So they've fed me a lot of work over the years. And, that sort of work can extend to, self-driving cars, aerospace projects, printers, photocopiers, that kind of thing. And it's a case of being able to take the software and put it on the customer's usually bespoke hardware, and then making sure that software is going to execute as it's supposed to do. There's a whole bunch of communications that happens on the hardware. And it's my job to get all those, all those device drivers and all those bits of software onto the hardware and working properly.
How has this journey sort of led you to becoming an IBM partner?
If I could kind of summarize, I suppose, what my company is about. So the whole reason for me to go down this path of creating this company and naming it Harmonic Software Systems is because I kind of realized early on that I somehow sort of define a level of quality. The way that I did that was to try and come up with my own philosophy on software development. It's kind of the beating heart of the company, this philosophy. As I say, if I can summarize it in a word, it's quality. With that in mind, particular sort of IBM tools, and the reason why I wanted the company to become an IBM partner is because of tools like Rhapsody and Doors. Those are the tools which allow you to essentially improve the quality of the software that you're delivering. So with Doors and requirements capture, you can define exactly what you want to deliver, what the software is going to do. And then with Rhapsody, you're able to model that in UML or to generate your code, and then in this case, download it to an embedded target where it will execute. And so these tools fit in with my philosophy, which is to produce software of the highest possible quality. I think nowadays it's all about pulling the right tools together to create your software. You're no longer in a position where you can just sit down with an editor and start writing some code. You've got to be able to put all the tools, all the infrastructure around it in order to, say, do continuous development, continuous test, modeling of your system. I saw the IBM tools as fitting in very well into the philosophy that I've got for my company.
Yeah, you talked about helicopters or photocopiers. And so software really is hidden away inside whatever the product is. It's embedded, as you said. But there are other industries that are out there that are trying to achieve this. They're kind of on this journey to become more reliable and inbuilt quality into their output. And they're on this sort of mission. So I suppose the question was going to be, and whether you think you could answer it, is more about, the industries you've worked with so far. I mean, you've touched on it in terms of a bit of aerospace you mentioned, maybe automotive. Are there signs that other industries are knocking on your door saying, look, we want to try and, drive quality into our product?
I don't think there are particular industries that are doing it. I think all industries have upped their game over, say, the past 15, 20 years.
Right.
Because the medical systems are having to focus very heavily on software quality as well.
Yeah, okay.
A very rigorous testing needs to occur, obviously, with medical systems. Sort of the industrial guys, I think that, everyone's starting to get into the AI side, how to optimize their processes.
Where are you with your message of AI to the people you talk to?
It's definitely moving towards the edge. Traditionally, you need a lot of computing power in order to be able to run an artificial intelligence system on a chip. But we're definitely getting to the stage now where the embedded devices are getting much more powerful, and you're able to take what's called a convolutional neural network and stick that on your small embedded device. For instance, we can see in the realms of preventative maintenance, where a customer might have some sort of industrial application, some sort of motor that's running, and it would be good for them to know that that their system is starting to degrade, let's say. We've been playing with a demo where we've got an accelerometer on a fan, and we're reading that data and we're reading it into a convolutional neural network. And we've trained it so that when we drop something onto the fan, in this case, it's just a cable tie, it causes the accelerometer to have a different set of waveforms, and our AI system can then detect that this is about to occur. To sell this as a kind of custom service to our customers, so that they can put this preventative maintenance into their systems. And it's all happening at the edge rather than what's been happening so far, perhaps in the cloud. There are various advantages to having AI at the edge. For a start, your data doesn't go off onto a public server somewhere where, with no security, no lag as well. So that small embedded chip that's able to detect something is about to go wrong, it's very useful to our customers.
I like it. I mean, I do a lot with kind of completely different industry and different speed, but real estate, facilities management, there's a huge shift to how can we become more edge aware inside buildings.
Yes.
There's a lot of things going into the cloud, which is okay, but it's not fast enough for how the human being might respond in a room or a football stadium or something. So this concept of edge is moving closer, I think, into the fabric of buildings. So that's great. Thank you.
It's an interesting example because, of course, we hear a lot about 5G coming along and how everything's connected and everything will get even more connected. Ed, you're working on often, as you say, safety critical stuff, and I guess you've got to cover the cases where communication will get lost.
It doesn't make sense to continually rely on some connection. As you say, it's good to have that information, on the ground, have it available there when you need it.
What is your view about the smartphone as an edge device? Do you think it is very like personal productivity stuff like we get used to, or has it got another role?
Do you mean is it going to morph into the next big thing that we don't even know about yet.
5G and what that might do for mobile technology, could be another paradigm shift. I'm sure that's what all the manufacturers will say.
Yeah.
But what would that allow us to do more? And what is the impact on your point of view? And it's really just, maybe it's a bit of crystal ball gazing. There's evidence of you could run machine learning on smartphones when they're not connected, and we've done some work with that already. And I'm just intrigued about whether that's something you talk about or think about.
Well, I mean, I guess it's inevitable, really. These chips, especially the ones that Apple seem to be able to create, they've got their own dedicated machine learning silicon nowadays.
Right.
And I think that the likes of Facebook and Twitter and what have you, and even Siri, it uploads its questions up to the cloud, and then you get an answer back. So you've got that level of delay. I mean, who knows what happens when you combine smartphone with an embedded AI chip, with onboard sort of speech recognition and speech technology, and then you stick the very low latency 5G communication on top of that. I mean, theoretically, you could get your smartphone to drive a car on the other side of the world, or to drive some virtual representation of yourself in another country in a meeting.
Anything's possible. Yeah. No,
that's it. Anything's possible. Yeah.
Ed, do you think you've covered enough around the philosophy of harmonic software?
I mean, there's lots of software development philosophies out there. DevOps is a software philosophy. And in terms of this philosophy, this was really born from my frustrations as a contractor. Often I'd get sent on site, when the system had been going for a few years and they needed some more heads in there to try and meet delivery deadlines that were slipping. And what I'd generally find is that they'd already spent, say, 12 months doing all the documentation for the system. And then maybe they'd spent about 6 months doing the development. And by the time I was on board, I'd have 6 weeks left to do all the testing before it was supposed to be delivered to whoever, to the MOD or somebody. And I could see that they just weren't thinking that it needs to be tested. When I came up with the philosophy, which is based on the whole concept of yin and yang, so it's the whole concept of balance, the whole concept of harmony. Yin and Yang is a very famous philosophical symbol representing things like night and day, weak and strong, fast and slow. And so I was able to kind of transfer that into a software philosophy that just encapsulated what I thought in my head good software was. And fundamentally, there are kind of 3 sections to it. There's documentation, and there's development, and there's test. I think a good software system needs all 3 together. Again, I'd go on site and I'd be given a document and it would be 6 months old. And I'm expected to work with that when actually it's out of date and there are things missing and it's not being updated. So the point of the philosophy is it's saying that the documentation, the development and the test, they all need to work together. They all need to harmoniously fit together. And they need to fit together in such a way that you're continually moving from one to the other. You're essentially doing an agile software development process.
I was going to ask you your thoughts around and how it relates to the what's now known as agile development.
Yes, I mean it is agile. Really, it's agile in the case of we can go through documentation, development, and test in a minute. When you're doing your code, you write your comments, you write a little bit of code, you write some test code, you execute it. That's happened in a minute. Or you could say the whole thing is 6 months if it's a long-winded aerospace project where there's an awful lot of documentation to be done up front.
That's why I think like model-based software development tools like Rhapsody are really, really useful, because effectively you're able to do that. Well, sort of like the document is almost like the model.
Exactly.
And the development is like, some of the behavior diagrams and maybe some of the snippets of code you put into it. But then of course you just click a button, it generates the code for you, executes it. You can then run some automated tests, or you can effectively do some like what if tests manually with the tool, find an issue and then loop back again. And you've got these like micro cycles of a whole set of activities. And it's just, I always find it a joy to work in that way. The thought of writing some code that you don't actually get to see work for days, weeks, months later is just, I think, a crazy approach.
Yeah, definitely. I mean, these tools do a lot of the heavy lifting for you. You know, they give you the framework on which you can come up with an idea. You can stick it in a diagram. You can generate your code, and you can execute it on the target, you know, within a very short space of time. And as a developer, I'm always trying to make this circle faster. Document, develop, test, document, develop, test. Get that as fast as possible. Get your debug cycle down. You don't really be wanting to wait 5 minutes, 10 minutes between each test where you're plugging something in, unplugging something, burning it onto the target, powering it up, see if it works. You want to get in the zone where this cycle is going as fast as possible. So these kind of tools all help.
The other thing that I noticed over time was that, you know, I think initially when I was a software developer, it was almost like an arms race in learning every nook and cranny of C or C++, or those sorts of languages. But actually, what's just as important, if not more so, is sort of the domain and the problem that you're solving. When you use a graphical engineering tool, you know, like Rhapsody, it allows you to concentrate a lot more around sort of behavior and the domain that you're working in. You know, you don't really care so much what C++ constructs being generated and things like that underneath, because it's, you know, in the same way you don't care what the assembler usually looks like. Okay, there are some situations where you do, but you just get used to accepting how things are.
Yeah, well, as a software developer, you're always in your mind trying to put all these different pieces of the jigsaw together.
We talked a bit about waterfall. We talked about agile. You know, I see a lot of, it's particularly in automotive, V model. What about the V model?
Yeah, well, I tried to kill the V model in 2005. I'm not sure that I succeeded, but I did write an article about it, and it's on the website. Because again, everybody uses the V model. It's absolutely everywhere and very good in some ways, but in some ways it's not so good. You know, I would go on site and I would see sort of defense customers, and they would say that they're using the V model, but they would say, well, we're going to use it. We're going to be a bit more clever. We're going to use it recursively. And they would cut and paste 7 or 8 of these V models together and stick it in their design documents.
Is that like a pseudo agile then?
Yeah, it's kind of the precursor to agile. Let's try and connect up things multiple times, but you'd never know which phase you were in of block 4 of the requirements document. You know, it would never be tracked or anything. It just didn't make any sense at all. The V model itself, very powerful in some ways. It's very good at linking your requirements to your system testing, your high-level design to your integration testing. Trouble is that it's sort of time is implied to move from left to right. So you come up with your requirements are complete, you move forward to the design, your design is complete, and you go through coding and testing, unit testing and integration testing. The reality is that it just doesn't work that way. I think that's why agile has become such a buzzword over the past 5 or 10 years, because you do learn as you go along. And as you go along, you realize we need an extra requirement. There is nothing in the V model that allows for change.
I mean, it's interesting because within the sort of IBM engineering tools, we sort of support the V model essentially through like a data model that we put in, configure inside the tool. So you've got different levels of requirements, test, maybe into models, and that's, for us, that's like a traceability model.
Yeah.
But that's orthogonal to actually how you build the assets that fit into that data model, if you see what I mean. That's like the framework for traceability, but actually how you then go and build the system and start filling in those different layers of requirements and the tests that validate them and things like that. That could be agile or some sort of time bot type development. But for me these days, I think of them as separate activities, really.
As a model, it's okay, you know, to understand elements of the software process, but as a framework from which to develop your software on, you have to be aware of where it falls over. You have to be aware that it doesn't handle change. And of course, the later you are in the software development process, when you discover bugs later in life, the more expensive it is to be able to fix them. Until you find a system level failure when you've delivered it, it can cost a lot of money to fix. So you obviously want to find your bugs early. The thing with the V model is it can sometimes be used as a kind of stick to beat people over the head with, to say, well, we're in this phase and we're doing this. It doesn't lend itself to any flexibility that needs to happen in the software development process in order to say, well, we've just got to go back and we've got to update a few requirements and we've got to rerun a few tests. It's the project management tool that batters people over the head.
Yeah.
That's the trouble with it.
Yeah, people are looking for things to be complete. Well, effectively, they're just saying, oh, you've got to use a waterfall approach. So you cannot move to this stage until you've completed all of that stage.
Exactly.
Like you say, I think we all know now that left shifting, as it's calling, or validation is the game in town really these days.
I mean, even for aerospace, which I do quite a lot of, I do quite a lot of DO178 testing. You know, that quotes the V model, but then when you look into the details of DO178, it does say you've got to have a mechanism to change things. You've got to have a mechanism to be able to find problems and to go back to the requirements and to update the requirements and so it's kind of, we'll use a fixed rigid model, but can we also have it adaptive and agile and change it at the same time?
What should people stop doing when they think about, approaching a project?
I can tell you how I run my project. What I do is I absolutely document everything in what's called an audit trail. And I've got these audit trails that have gone back over 20 years. And then I'm able to search them all and go back in time and answer questions about what I did at that time. Because most people do job day to day. And, if you're lucky, you've got a lab book and you write in your lab book and I turn this on and I turn that off. But sometimes when you're testing embedded systems, you have to go through a whole list of very intricate tests. Sometimes it's this kind of, I call it a hack and slay approach. So you try and cut a problem in half. You'll turn this switch off. You'll turn that switch on. You'll unplug this. You'll plug that in. And before you know it, you've done 8 or 9 different things and you don't know where you are. So I document everything sort of meticulously in an audit trail. A few days later, I'm trying to figure out, well, did I actually test that? Did we test all 3 Ethernets plugged in, or was only 2 of them plugged in? Because the customer's saying it doesn't work now with 3 Ethernet. Then I've got that information there. I've got every test I've run, all the evidence all goes into a document. Any bug that I have kind of goes in. So I'm able to go back years and years and search for how I did things then, or what tests we did, or what the results of a test were. And it fits in with the philosophy. It's to document everything. In fact, Audi was a good one because I worked with Audi for about 6 or 7 months on their self-drive cars, and they had an ARM chip in it. And there was a particular sequence of commands to kind of enable the security layer. And that was one of the tests, is the security layer enabled in the ARM chip. A couple of years after the project had finished, I got a call out of the blue from an engineer saying, hey, we know you did this, but we don't know how you did it. How did you, which bits did you press on, which registers did you talk to enable the security layer on the ARM chip? And, once I kind of knew where to look, pretty simple. You can search it, you can find it. The cut and paste was there. There you go, email back. And, 2 minutes later, I was back working with the job that I had to do that day, rather than hunting through the user manuals and trying to remember how did I do it years ago.
It's almost like a form of what we do inside sort of our engineering tools in terms of like the configuration management, and every little change, every change to a requirement, be it changing a word or changing an attribute value, it's all logged. So you can always go back in time and exactly who did what and when. And
all my employees do that as well. They use the same tool to be able to track what they do. In fact, I've even got the sales director learning this tool, which took a little bit of persuading, but now he loves it because whenever he talks to somebody, he writes down who he talked to, what time it was, what they said, and it's all instantly searchable, and I can see it and everybody can see it. So I've got a visibility of what every employee is doing, in the company. I've got 6 monitors here. I'm looking forward to the day where I can have a whole bank of monitors with everybody's audit trails on, and I look at them and see what they're up to.
We've got a picture of you in years to come surrounded by machines.
Exactly.
This last question, 2021, what's your big hope?
Personally, I'd like to have more fun. I was knee deep in a avionics project, and it did get very, very tedious and very difficult. So I want to have more fun in software. I want to have more fun creating these AI demos and getting into the really interesting side of embedded systems. I was able to play last year with some embedded vision, facial recognition, that kind of thing. But that was on the PC. I'd like to move it into embedded systems, into edge AI.
Thank you, Ed. It sounds like being a partner with IBM is probably a good place for you to be there. And there's so much that you've talked about, which I think is going to be very interesting. Steve, thank you for your help on the podcast. It's been great to have a colleague with me asking some really challenging questions of our guests. And Ed, of course, good luck in 2021 for you and your company. I'm sure it's going to be a great success. And anyone listening, if you've enjoyed the podcast, please tell others and have a good day.